So today we will discuss about assessment 3 question 6. So look at the question. An open top aquarium with a volume of 36 meters square is to have the length twice as long as its width. Let X and Y be the aquarium width and height respectively. So first thing first, we should highlight the keyword. Open top aquarium, volume of 36 meters square, length twice as long as its width, and last, X, Y, width and height. Next, we should draw the aquarium. So this will be the height, this will be the length. The length is twice as long as width. It means that this width is double to get this length. So this is length, width, height, width and length. So we will get the aquarium. The height is 1 and the length is 2x. The width is x. But don't forget, the top is not included in this calculation. It is because this question says that open top aquarium. This means that the top is not included in calculation. So to solve the question A, I will pass to my friend Amirul.
Now let's look at the question A. Express y in terms of x. To answer this question, we need to use the volume of the aquarium. V equals to length, y, height. From this, we just need to take the information from the question, and it will be 36 equals to length to x, y, x, and height, y. And it will be 36 equals to 2x squared y. And then express y in terms of x. Take 2x squared to the left, it will be 36 over 2x squared over y. Take the y to the left, will be y is equal to 36 over 2x squared. That's for the question A. Then my friend Anik will be explain the question B.
Now let's take a look at the question B. Show that the surface area of the box is given by A equals to 2x squared plus 108 over x. To solve this question, we need to calculate all the surface area of the open top aquarium. So we need to write A equals to all the surface area of the open top aquarium. The first surface area of the top aquarium is here, 2x and the height is y. So we have two same surface area here and the back of the open top aquarium. So we have to write 2 times 2x and y. Next, we need to write the surface area here. The surface area here is x and y. So we also have two same surface area. So we need to write 2 times x and y plus the bottom of the open top aquarium here is 2x and x. So we will write 2x squared. So when we calculate this, we will get 4xy plus 2xy plus 2x squared. We will get 6xy plus 2x squared. Now, we need to substitute y. We have already get the y. The y is 36 over 2x squared. So we can write it as y equals to 18 over x squared. Now, let's substitute the y in this equation. So, we can write a equals to 6x times 18 over x squared plus 2x squared. When we calculate this, we will get 108x over x squared plus 2x squared. So we can write it as 108 over x plus 2x squared. Now, it shows that we have the same equation as the question given. It shows that we already proven the equation. Next, my friend Mohammed will explain the question C.
Okay, now we will discuss the final question of 6. Find the minimum surface area of the box. And to find the minimum surface area, we need to find the volume of x and minimum volume and y and volume of x, and we can get the minimum surface area. At the first step, we need use the first derivative. By using the question a, we get before this a, and we can write a equals to 2x minus 100 x over x, and we need to differentiate, and we can write dA over dx equals to 4x minus 100 over x squared. And the next step, we need to compare dA over dx with 0 to find the minimum of to find the volume of x, and we can write 4x minus 100 over x squared equals to 0. Okay, we need to solve it with moving this to that, and we write we for x equals to 108 over x squared, and we can simplify that, and we can write 4x cubic equals to 100x, and we can solve it. X equals to 3, and the next step, we need to use the second derivative to find the minimum volume, and we can write second derivative. We need to differentiate again the dA over dx, and we can write dA over dx equals to 4x minus 108 over x squared, and we differentiate it. It will be d square a over dx square equals to 4 plus 260 over x cubic. And we substitute this question with w y we get yx, the value of x we get before this, and we can write x when x equals to 3 will be 4 plus 260 over, we put here 3 cube, and write 12. As we know, 12 is a bigger number than 0, so we can compute that there is x equals to 3 is the minimum value. So after that, we need to find the volume of y. To find the value of y, we need to use x. We can write when x over 3. We need to use the equation y, and we get before this. X equal to t over x squared, and the answer is y equals to 2. And the final step, we can compute the minimum surface area by put x equals to 3, and we can write minimum surface area so we need to use the equation of A. We can write 2x squared plus 108 over x, and we substitute the x over 3, and we can write 3 squared minus 108 over over 3, and we can write, and the answer is 54 meter square, and it's going to be the final answer. So that's all for me.